Mount Rainier shook over 10,000 times in less than a month. And then nothing. Not silence from the mountain, but silence from the monitors. The quakes didn't just stop. The reporting did. Since July 8, 2025, one of the most dangerous volcanoes in the United States has been caught in a seismic swarm unlike anything seen at Rainier in recent years. We're talking thousands of micro-earthquakes and tremors in just a few weeks, centered around a zone of deep hydrothermal activity beneath the ice-capped peak. The kind of swarm that grabs attention. The kind that raises eyebrows in scientific circles. The kind that makes you wonder what's really happening under the surface. If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next. And you being here keeps the conversation going. Thanks for watching. See you in the next one. But the deeper the story goes, the more it's not just about the mountain, it's about what we're not being told. At first, the official narrative came quick. It's probably surface level stuff. Ice cracking, rock slides, wind, harmless background noise. Nothing volcanic. No magma. No eruption. Everything's normal. But underground sensors were still lighting up. Quakes were still happening. And more importantly, the type of seismicity didn't exactly match the surface disturbance explanation. The quake depths ranging from 2 to 6 kilometers weren't near the surface at all. They were right in the zone where you'd expect to see hydrothermal activity. Right where superheated water and steam move through fractures deep inside the mountain. And the people watching closely noticed. Independent seismologists, citizen scientists, curious observers with access to raw data streams. They saw the tremors. They watched the waveforms. They knew something was still happening and the official channels were no longer showing the full picture. So the question isn't just what is happening. It's why don't we know more about it? This isn't some backyard hill. This is Mount Rainier, a massive, glaciated stratovolcano capable of producing not just eruptions, but catastrophic lahars that could devastate communities across the region. Rainier's biggest threat isn't lava. It's its ice. And the combination of a warming system underground with a massive ice cap on top is a worst-case scenario. Sudden melting, landslides, mud flows, events that can occur with little to no warning, especially if the first signs are missed or ignored. And that's where transparency becomes more than a buzzword. It becomes a life or death issue. Because how do you plan evacuation routes, train response teams, or inform residents when your information source is inconsistent? If some stations are going dark, and others are adjusting data downward, how are local governments supposed to trust the situation is under control? How are researchers supposed to assess real-time risks when part of the dataset is missing? Even more concerning is that this isn't just a Rainier problem. It's a Cascadia problem. The entire Cascade Range sits on the edge of the Juan de Fuca subduction zone, where one tectonic plate is diving under another, feeding magma into the crust, building pressure and fault lines, and creating the perfect storm for both volcanic and megathrust earthquake activity. This geological setting doesn't just make seismic swarms more likely, it makes them more meaningful. Because deep fluid movement and tectonic slip can be signs of shifting stress in the system. And Rainier, being directly above that action, is a sensitive indicator. So when tremors start rattling from 2 to 6 kilometers below the summit, in zones tied to past hydrothermal activity, that's not background noise. That's the volcano talking. And when the response is to lower the volume by pulling stations offline or reducing data visibility, that's not science, it's spin. This isn't about blaming any one agency. It's about accountability. Because when the USGS or the Pacific Northwest Seismic Network present a story that doesn't match the raw data, or when they say normal activity, while simultaneously going quiet on quake counts, they invite skepticism. Not just from fringe theorists, but from actual scientists who rely on that data to do their jobs. And let's not pretend this is over. Even now, there are signs that seismic activity hasn't stopped, it's just been pushed out of view. Independent tracking tools continue to show low-magnitude tremors beneath Rainier, activity that's consistent with ongoing fluid migration, even if it's not trending toward eruption yet. The system is still under pressure. The mountain is still whispering, and it doesn't take much for that whisper to become a shout. Historically, swarms like this can last weeks or months. They can pause, then resume. They can simmer quietly before escalating, or they can fade entirely. But every time one happens, it becomes part of the bigger picture, a signal in the dataset, a chance to refine models, improve forecasts, and test warning systems. Which is why scaling back data during a swarm is the worst possible move. If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next. And you being here keeps the conversation going. Thanks for watching. See you in the next one. This was a chance to learn, to prepare, to engage the public in meaningful, informed conversations about risk and resilience. Instead, we got silence, missing quake counts, and a growing divide between what's happening underground and what's being shown on the surface. Rainier is still there. The tectonic plates are still grinding. The fluids are still moving. And the people who live in the shadow of that volcano, they're still waiting to be told the truth. So here's the takeaway. Whether or not this swarm leads to an eruption matters. Not just because of what it says about Mount Rainier, but because of what it reveals about how we handle volcanic unrest in the age of instant information. Are we sharing real-time insights? Or are we filtering the story for the sake of public calm? Because the people downstream from Rainier don't need reassurance. They need accuracy. They need honesty. They need all the data, not just the parts that fit the narrative. This isn't just a geological event, it's a test of science, of communication, of trust. If you're following this and thinking, why isn't this getting more attention? You're not alone. And if you're wondering what else we're not being told, keep watching. Because the story of Rainier isn't finished. The plates are still moving. The signals are still coming. And the mountain has a long memory. So what do you think is going on? Is the data being withheld to prevent panic? Or is there more beneath the surface than officials are willing to admit? Drop a comment. Start the conversation, and let's keep asking the questions that need to be asked. Like this video if you want more coverage on stories the headlines skip over. Subscribe so you don't miss the next update, because this volcano isn't done. And share this with anyone who thinks seismic swarms don't matter. Because when the mountain speaks, we need to be listening with eyes open, data intact, and no filters in the way. The silence isn't comforting anymore, it's deafening. When Mount Rainier's seismic swarm exploded into view in early July 2025, it should have been a rallying cry for geologists, emergency planners, and communities in the danger zone. 10,000 tremors in under 30 days? That's not business as usual. That's a volcano reminding everyone it's still alive. But what happened next wasn't a deeper investigation or more detailed communication. What happened was a vanishing act. The data stream that had been flowing freely, the same stream showing deep, persistent quakes centered in zones historically tied to hydrothermal activity, started thinning. Some seismic stations dropped off the map entirely. Others stayed online, but the output looked off. Less activity, fewer plotted events. A pattern that felt less like a natural pause, and more like a quiet hand over the mouth. That's what set off alarms. Not the seismic swarm itself, but the way it was handled after it became too loud to ignore. And here's the thing. This isn't just about public perception or media spin. This is about scientific integrity. The moment you start tweaking or omitting data during a live volcanic unrest sequence, you are no longer documenting the event. You're managing it. And for a volcano like Rainier, that's not just irresponsible. That's dangerous. Because Rainier doesn't play games. The mountain might look serene from a distance, but its past is anything but calm. It has a long record of explosive eruptions, collapsing flanks, and catastrophic lahars. In fact, some of the most destructive flows from Rainier didn't even require a full eruption. A simple internal shift destabilizing a slope beneath its massive ice sheet was enough to unleash avalanches of volcanic mud that traveled for miles. That's the risk we're talking about here. You don't need a plume of ash to justify constant monitoring. All it takes is heat migrating upward, pressurized steam finding a weak spot, or a landslide triggered by internal shaking, and suddenly, you've got rivers of debris flowing down valleys where people live, work, and commute daily, which is why the decision to downplay this swarm intentionally or not feels reckless. Let's get into the actual characteristics of this unrest. The quakes didn't just pop up randomly, they migrated. They formed clusters. Their depth ranged from 2 to 6 kilometers beneath the summit, right where Rainier's hydrothermal system lives. This isn't shallow crust noise or ice settling on the surface. These are signs of fluid pressure shifts, deep underground, inside fractured rock. These kinds of swarms have been documented at other volcanoes, Yellowstone, Mammoth, even Mount St. Helens. And in many of those cases, the cause wasn't immediate magma movement. It was fluid migration, superheated water or gas traveling through pressurized pathways. Sometimes it led to an eruption, sometimes it didn't. But in every case, it provided critical information about the state of the volcano. And yet here, when it's Rainier, the volcano with the potential to bury entire communities under volcanic debris, that same kind of data has been reduced, filtered, or just gone. This isn't a conspiracy theory, it's a pattern. The seismic counts don't match the tremor signals. Some stations that were showing activity suddenly went dark. Others show reduced sensitivity. And official communications? Still leaning on the idea that it's just weather noise or ice cracking, which, again, might be believable if it weren't for the depth, and the waveform patterns, and the sustained nature of the swarm over weeks. Let's talk about the tectonic context here, because that's a critical part of why the story is so serious. Mount Rainier doesn't exist in a vacuum. It's part of the Cascadia subduction zone, a region where the Juan de Fuca plate is slowly sliding under the North American continent. This process injects water and heat deep into the crust, generating the magma systems that fuel the Cascade volcanoes. So when a seismic swarm like this occurs, especially one that's consistent with hydrothermal or magmatic fluid migration, it needs to be understood in the context of long-term tectonic pressure. This isn't just a temporary twitch in the earth. This is an expression of deeper forces reshaping the crust from below. And that's exactly the kind of thing seismologists should be watching closely. But what happens when the very agencies tasked with watching that data start going silent? That's when people lose confidence not just in the science, but in the entire system built to protect them. Because it's not just about whether Rainier will erupt tomorrow. It's about how much time people have if things start escalating. And it's about how early we can detect that escalation. Right now, the signs of an imminent eruption aren't there. No ground deformation, no gas emissions, no strong, shallow quakes that usually indicate magma is moving up through the system. But what is there is a sustained, deep-seated swarm, and a mountain with a long memory. One whose last major eruption was long before modern instruments were even invented, and whose internal systems are hidden beneath layers of ice, rock, and time. In that kind of setting, the absence of surface signals doesn't mean the system is stable. It just means we haven't seen the effects yet. And that's why this event matters so much. Because swarms like this could be nothing, or they could be the first domino. And when the difference between nothing and catastrophe can happen in a matter of hours, you don't get a second chance to wish you had more data. The irony here? This event could have been a scientific goldmine, an opportunity to observe a high-volume swarm in real time, to test new modeling tools, to refine forecasting algorithms, to educate the public about how volcanoes behave beneath the surface, to build trust by sharing every step of the process. Instead, the agencies pulled back. They trimmed the data, they removed quake counts, they dialed down the transparency during an active swarm, and in doing so, they've turned what should have been a textbook case study into a lesson in lost trust. Because once you start asking, why did they stop publishing the data? You open the door to every other question. What else aren't they telling us? Are they reclassifying tremors to make the counts look lower? Are they minimizing risk to avoid headlines? Are they afraid of public reaction? And maybe none of that is true. Maybe it's all just a series of technical glitches and miscommunications. But that's not the point. The point is, when the data goes quiet and the mountain doesn't, people notice. And they should. Because beneath Rainier's icy crown lies a complex and restless system. A system of pressurized fluids, shifting rock, and glacial weight pressing down on fractured crust. A system that could explode or not. A system that only reveals its secrets through data. The kind of data that's now selectively visible. So where does that leave us? With a volcano still trembling. A seismic swarm that hasn't been fully explained. A tectonic setting that remains one of the most volatile in North America. And a public that's been asked to take official reassurances at face value while the evidence behind those reassurances fades from view. The mountain waits. The plates grind. The pressure builds. And if we don't listen now, when it's whispering, we may not have time to react when it finally speaks in full. Let's talk about what happens when silence becomes strategy. When seismic stations start going dark during a swarm of over 10,000 earthquakes, you have to ask, who made that call? And why now? Because here's what we know. Mount Rainier's internal system, the deep zone where hot fluids travel through fractured rock, doesn't just switch off. These are processes driven by tectonic pressure and volcanic heat, and they don't respond to press releases. So when the data feed slows down or drops off entirely, it's not because the mountain stopped moving. It's because someone, somewhere, decided the public didn't need to see every tremor. That's not science. That's messaging control. Let's be very clear, there's no confirmed magma movement, no surface swelling, no emissions. And that's good news. But that doesn't cancel out what the raw data was showing: ongoing deep seismic activity, concentrated around hydrothermal zones, with patterns that didn't match simple surface noise. That kind of activity might not mean eruption is coming tomorrow, but it's exactly the kind of behavior that precedes major shifts inside a volcanic system. And in Rainier's case, any shift, any escalation in seismicity, heat, or gas has serious implications. We're not talking about hypothetical damage. We're talking about a mountain that's generated lahars capable of reaching the Puget Sound lowlands in hours. A volcano with a direct line to river valleys packed with homes, schools, and highways. If the warning signs get missed or worse, deliberately filtered out, the consequences will land on the people who were told everything was within normal parameters. And that phrase, normal parameters, has become a kind of catch-all. It sounds official. It sounds comforting. But when it's used while earthquake counts are quietly being reduced, it becomes a shield against accountability. Because what's normal for a volcano like Rainier? 1,000-year silence. Catastrophic floods without eruptions? Seismic swarms with no surface deformation? Like this video. If you're tracking this story as closely as we are, share it with anyone who lives near the Cascades or relies on these agencies for emergency info. And leave a comment. Do you think we're getting the full story about what's happening under Mount Rainier? Because in a system built on trust, filtered data speaks louder than earthquakes. And sometimes, the quietest moment says the most.